Hi, and welcome to Module 4 of Lecture 4. In this module, we're going to discuss some different models from the ones we've seen before, but they have very similar ideas. And the point is not to throw at you a whole bunch of models in very short order, which wouldn't be very useful to you, but rather to show you how far you've come by taking this course, because these models you've never seen before will still be interpretable by you in some very important ways. So far we've discussed continuous dependent variables primarily, with ordinary least squares, either bivariate or multiple regression formats. In the last module, we broadened this to a logit model in which we can capture dichotomous dependent variables that take values of 0 or 1 only. They only take binary values. The probit is another kind of model we discussed not really much at all, but it has very similar properties to the logit in that context, just a different functional form for how x affects y. What if we have different kinds of variables, though? What if we extend it to having more than two categories? So if they're ordinal, with ordered categories, we can use what's called an ordered logit. If instead we have a nominal variable with no natural order between the categories, we can still use a regression format with a multinomial logit. What if we don't have categories at all, but instead we have counts? What if we have situations in which we're counting the number of times something happens, the number of attacks that might occur in a certain time period, or the number of uses of a particular policy over a certain time period, right? These are all counts. They're pretty common in the social sciences to count the number of events that happen. And there are many different ways to analyze this. Some of the more straightforward ways involve a Poisson model or a negative binomial model when you see some of the assumptions that are needed for the Poisson model are violated. But there are more complicated types of counts, where, for instance, you have to surpass some hurdle, some threshold, before you can start getting past 0 in the first place. There are hurdle models or zero-inflated models of counts. There are lots of count models. You might also have a situation you want to model in which you care not about counts, but about the time until some event happens. This occurs, for instance, and you can see my IR sort of comparative bias here, I guess. Not bias, just knowledge. This happens a bunch when you are looking at the time into war reoccurs after a resolution to a previous war, right? You want to understand how effective treaties are, and you can do that by seeing how long it takes for the treaty to stop being effective, right, until war starts again. Just the time until an event happens. And there are a lot of models of these as well, like, for instance, the Cox proportional hazard model is just one. The thing here is when you go in practice to go use a model, what you're going to do is you're going to have a research agenda, research questions you want to answer. You'll see what people have worked on. You'll see what kind of data you have access to, what kind of data generating process underlies the data you have access to. You'll see what kind of dependent, independent variables you have, what kind of models you need to run to analyze properly those dependent variables, and you will learn as needed about the models that you need to use. Some of these you're learning in class. If you go on in this, some of these you will learn just because you have no choice, because that's what you need to do your analysis. The cool thing is you already know a lot about them from just going through this course. You can still, in all these cases, use the coefficient estimates you get from the models to perform hypothesis tests. You'll still be able to understand hypothesis tests in regression models you've never seen before. And the end of this module will show you one example of that. That said, you won't get everything. Just like for the logit, you won't be able to automatically interpret the meaning of the coefficients in different kinds of models. Sometimes you require more work to back out the meaning, the substantive meaning of the values of the coefficients in your regression models with other kinds of models than the standard OLS model. But even then, you'll still be able to, in many cases, look at the coefficient estimates and figure out if you have a significant relationship between the x and the y variable, or in other words, if you can reject the null hypothesis that there is no relationship between the independent and dependent variables, which is great. And we're going to see one example now using a model you have not seen before, the ordered logit model. So this is an overall agenda which you want to understand how people viewed President Clinton at the conclusion of his administration. In particular, you answer the question, since President Clinton took office, has the president made the moral climate in this country better or worse, or has it stayed the same? These are three categories. We can order them from worst to the same to better. So we're going to use an ordered logit because that's our dependent variable, an ordinal variable. Here we have multiple independent variables. There's a party variable. Instead of dummies, it's a party variable. we expect Democrats to have more likely to say better than Republicans in this case. There's an education variable for highest degree attained. There's an age variable. There's a regular churchgoer dummy variable, because we're talking about moral climate here, so it seems like it might be relevant. And there's a gender dummy here, with I think female being 1. Again, this is a dummy because historically they've only used 2 categories for gender variables, which has been changing recently. Results of this model, we have what you expect to see normally, right? So ignore down here. These involve cutoffs. Just forget about them. Look at the coefficients on the variables and the z-value, right? Like the statistic, the t-statistic here, right? We see the party has a coefficient of this, and we can't interpret it necessarily easily, but let's ignore that. The party has a z-value of 13, which means party is a significant predictor of how one answers that question about moral standing, or moral climate. Education has a z-value of 5, which also means it should be significant at both levels. Age has a z-value of 1.2, so maybe not significant, probably not significant. We'll compare in a second. Church going has a value of 3.6, so probably significant. And female here, the gender variable, has a significance of 1.9, so that's going to be borderline. So to remind you of what, the one-tailed test is 1.645, the two-tailed is 1.96, those are critical values. So even though this is a totally new model you've never seen before that involves funky tau cutoffs, these are lowercase taus, that you can ignore, you can tell just by using what you learned before that in this model, party, education, and church going are significant predictors of one's opinion on the moral climate change during President Clinton's time in office at the 95% confidence level. Gender here is a predictor at the 90% confidence level. Or if you had a prior belief about about that women would be less supportive of the moral climate beforehand, you could have done a one-tailed test, and this would have been significant at the 95% confidence level for a one-tailed test, and age is not for any of these levels. That's it. So you now know how to read all these regression tables regardless of the complexity of the model that you're given, which I think is great, and will also help you go on and read more of the literature and learn more about what you're interested in. So that's it for the set slides. In the last module of this lecture, we're going to go through and do some math on some of the stuff we talked about and show some pictures that might help you understand some of the earlier concepts in this module. Otherwise, thank you very much.